Hello friends, uh, we have done one problem on series and parallel resistance, and we calculated error and percentage error in the series resistance and equivalent parallel resistance. Now here I am having one more problem. We can just read it out. For estimation of Young's modulus of a wire, the formula is given: y is equal to 4 mg upon pi d square, and then that multiplied by capital L upon small l. Given that L is equal to 2.890, M is equal to 3.00 kg, D is equal to 0.082, G is 9.81 meter per second square. We have our small l as 0.087 meter, and now they want us to calculate the maximum percentage error in the value of y. Okay, and also we need to mention which physical quantity causes maximum error. Now here they are asking us to calculate maximum percentage error in the value of y. In the last problem that we did, I had R1 is equal to 8 plus or minus 0.5 ohm. That was given. What about that delta R or delta L, delta M, delta D, delta G, or then delta small a? It appears that it is not given, but then it is still there in the problem. It is there. I'll show you how. We had discussed significant figures, and then from significant figures we came to error. Correct. In significant figures, we had said that the last digit, correct, last digit of as stated in the physical quantity, its last digit is not trustworthy. It is not reliable. Okay. So that means my last digit over here, last digit over here, last digit over here, and last digit over here and over here, they are not reliable, right? And then plus or minus 1, that much uncertainty is going to be there. So that means I have my delta L as, now this has got 3 decimal places, so 0.001 meter. My delta M is equal to 0.01, correct. I have 2 decimal places over there, and that is where you would understand why I have written 3.00 and not 3 kg. If I write 3 kg, then that 3 would not be reliable, correct. In order to make that quantity a reliable quantity, I have added this. So that means what is the least count of the measuring instrument that I am using? It would be 0.01 kg, and 0.01 kg would be equal to 10 gram. Okay. Now here delta D, my delta D is again 0.001. This was kg and this is meter. My delta G is 0.01 meter per second square, and delta small l, that is 0.001, correct. So now my delta y upon y would be equal to, now we are going to use the formula that we have derived so far. So they have asked for percentage error, then I will have to multiply this by 100, and then that would be equal to, now obviously 4 is a constant quantity, I don't have to take that into consideration here. So it would be delta M upon M plus delta G upon G plus delta capital L upon L plus delta small l upon L plus twice delta D upon D. and then that multiplied by 100. Correct. Now why have I taken 2 times delta d upon d? It is because power of d is equal to 2. Correct. And alright, then I'll write here my delta m is how much? Delta m is 0.01 upon my value of m is 3 here, plus delta g is 0.01 upon 9.81, plus delta L is equal to 0.001 upon delta L, right? So it is equal to 2.890. Now while writing here, I write 2.89. That would be alright. Even here I have written 3. Correct. Plus delta L, again small l. So 0.001 divided by, it was 0.087, plus twice 0.001 upon how much is d? 0.082, and this whole thing multiplied by 100. Now you can just make the addition, multiplied by 100, and you will get the answer here. Correct? That would be percentage error in measurement of y. Now my second part of this question is mention which physical quantity causes maximum error. Now here you can see delta m upon m, delta g upon g, delta L upon L, delta L upon L, but here I have twice delta d upon d. So then this d, this quantity d, I don't know what is d. Okay, they have just given me the formula and they have given me the symbols, they have given the values. Okay, and over here what I see is it is delta d upon d is the maximum error causing component here. So I would say quantity d is causing maximum error. Now here alright, we have calculated and we have made some inference here, that is all fine, but then I just wanted to discuss one thing here, that these errors, okay, the errors in measurement, are they causing any adverse effect of on overall calculations? I think we should talk about that. We'll do that in the next video. Thank you so much.